Trigonometry, an introduction. Sine, cosine and tangent. Trigonometry. We use trigonometry to find the size of missing sides and angles in right-angled triangles. Let's look at an example. We've got a triangle with an angle of 36 degrees, a side of 12 centimetres and another side labelled x. We're asked to find the length of the side x in the diagram. To solve this, we have three stages. Stage 1, name the sides of the triangle. Now, in each triangle there will be one right angle and one marked angle. The longest side, opposite the right angle, is called the hypotenuse. The side next to the marked angle and the right angle is called the adjacent side. The side on the other side of the triangle from the marked angle is called the opposite side. Now, in stage 2, we select the correct trig ratio. There are three trig ratios: sine, cosine and tangent, or sin, cos and tan for short. If we look at the triangle, we have sine x is equal to opposite over hypotenuse. The cosine of x is adjacent over hypotenuse, and the tangent of x is opposite over adjacent. We can remember this by remembering SOHCAHTOA. Stage 3. Write out the equation and solve it. In this case, the marked sides are adjacent and opposite, so we use TOA. So the tangent of the angle, tangent of 36 degrees, is equal to the opposite over the adjacent. And if we put in the values, we've got tangent of 36 equals x over 12. If we multiply both sides by 12, that gives us 12 times tangent of 36 is equal to x. Now we can work this out using a calculator, but make sure it's in the degree mode. We type in 12 times tan in brackets 36 equals, and that gives us an answer, x equals 8.7185103. Well, we usually round it off to three significant figures, so that's x equals 8.72 centimetres. Let's look at an example. In the diagram, calculate the length of x and the length of y. Now to do this for part 1, name the sides. Now we're given that the angle is 33 degrees, the opposite side is x, and the hypotenuse is 14 centimetres. So we're going to use SOH. Sine is opposite over hypotenuse. So the sine of 33 degrees is x over 14. And we multiply by 14. This gives 14 times sine 33 equals x. We type in 14 times sine 33 and the calculator shows 7.624946. So to round it off to three significant figures, our answer is x equals 7.62 centimetres. Now, for part 2, we have the angle is 33 degrees, we're told the adjacent side, y, and we're told the hypotenuse, 14. So this time we're going to use CA. Cosine is equal to adjacent over hypotenuse. So the cosine of 33 degrees is equal to y over 14. If we multiply both sides by 14, that gives us 14 times cosine 33 equals y, and when we type that into the calculator, we get 11.7414. And so, rounding it off, our answer is y equals 11.7 centimetres. In example 2, we're given a triangle and we're asked in the diagram calculate the length x and calculate the length y. So for part 1, the first thing to do is name the sides. Now the angle is 64 degrees, and we have the opposite side is 8.6 and the hypotenuse is x. So we're going to use SOH, S-O-H. So the sine of the angle is opposite over hypotenuse. Sine of 64 degrees is 8.6 over x. Now we multiply both sides by x. This gives us x times sine of 64 equals 8.6. But we want x on its own, so we divide by sine of 64 degrees. And that gives x equals 8.6 over sine of 64 degrees. Now, typing that into our calculator, we find x is equal to 9.56838. And if we round that off, x is equal to 9.67 centimetres. Now in part 2, we've got the angle is 64 degrees. This time, the opposite is 8.6 and the adjacent is y. So we're going to use TOA. Tangent of the angle is opposite over the adjacent. So the tangent of 64 degrees is 8.6 over y. Well, if we multiply both sides by y, we get y times tangent of 64 equals 8.6. If we divide both sides by tan of 64, that gives y equals 8.6 over tan of 64. And if we type that into our calculator, y equals 4.1945. So rounding it off, our answer is y equals 4.19 centimetres. In example 3, again, we've got a diagram and we've got to calculate the size of the angle theta. Now, to solve this, we name the sides. We've got the angle is theta degrees. We've got the opposite is 11.3. And we've got the adjacent is 17.5. So with opposite and adjacent, we're going to use TOA. Tangent of the angle is opposite over the adjacent. So the tangent of theta is equal to 11.3 over 17.5. And to calculate theta, this time we're going to have to take the inverse tangent of both sides. So the left-hand side becomes theta, and the right-hand side becomes inverse tangent, 11.3 over 17.5. Well, to type this into the calculator, we're going to have to type shift tan, brackets, 11.3 divided by 17.5, close brackets, equal, and we get theta is equal to 32.8509 degrees. So rounding it off, our answer is theta equals 32.9 degrees.